Okay, so looking for help on numbers 5 and 6 from 4-6. I think this is the one you asked about. You didn't include a section number um, in the email. Do that in the future if you can. Now, um, this section is all about isosceles and equilateral triangles. So we're going to be trying to work with one of those things, isosceles or equilateral. Now, which one we're going to have depends on the number of sides that we have that are congruent. Isosceles has two congruent sides, and equilateral has three congruent sides. So, another thing about the equilateral is all the angles are 60 degrees, and for isosceles, the base angles are congruent. So we're going to, oh, I drew all that stuff underneath my webcam. Let me just turn my webcam off. Sorry about that. So I just kind of take some little notes there about what isosceles and equilateral are. Now, we're trying to figure out whether or not these two problems are isosceles or equilateral. And there are some clues to figure that out. For number 5, the clue that I know that this is isosceles is that the two base angles here are congruent. And if those two base angles are congruent, then we know their opposite sides are equal to each other. And that's what we're going to use to set up the equation. For number 6, I notice here I have two sides of length 8. That means that this is an isosceles triangle, and that the two base angles, the two base angles are also equal to each other, just like before. It kind of works back and forth between the two. So that's what we're going to use to set up the equations. And if you want to try to set up your equations now that you know that, pause the video, and when you think you've got the setup, um, go ahead and unpause the video, and you can see what I have. Okay, so for number 5, got the two base angles there. Tell us the two sides are equal, which means 2z minus 15 equals 9. And for number 6, two base angles are congruent. That means angle x here, which is 62 degrees, equals 4x minus 2. Now, you got to be careful here. Remember, the capital X is the name of the point of the vertex. So it's the name of an object. The lowercase x here is a unknown number value. So even though they both have x's in it, they're not the same thing. One's capital, one's lowercase. All right. Now, if you set those equations up the same way that I did, then you're good. That's the right step to take. Now all you have to do is find each variable, and you do that by solving each equation. Go ahead and pause the video again, and then unpause it when you're ready, and I will show you the process I used to solve these equations. Okay. For number 5, I see I have a variable on the left-hand side and no variables on the right, so I got to try to isolate that variable z. And to do that, the first thing I'm going to do is I'm going to add 15 to both sides. Because the z term, I need to have it isolated, uh, and we're subtracting 15 from it. I got to do the opposite to get rid of it. And that gives me 2z equals, well, 9 plus 15 is 24. Z is almost by itself. It's just being multiplied by 2, so I do the opposite. I divide both sides by 2, and you get z is 12. And we have found the value of the variable. Now, it does happen sometimes where you have to plug these things back in and find it, but I bet if we were to plug in 12 for z, we would find that that whole length of that side of the triangle is 9 because it's isosceles. All right. For number 6, and here I notice I have the variable on the right hand side. I'm actually going to drop the degree symbol, so I'm just going to have 62 equals 4x minus 2. Same kind of process, add 2 to both sides. 64 equals 4x. Divide both sides by 4, and you get, I'll write it over here on the right, x equals 16. Now, if you didn't know that in your head, of course, you could do long division or just grab a calculator. Don't let little calculations be the thing that throw off all the precious time you spend on the homework. Something simple like that. If it doesn't pop into your head pretty quickly, just grab a calculator. You'll eventually learn it from doing it so much. All right, and that's how you do 5 and 6. Now, this is helpful, and the reason why I did it for both of those problems is there's a bunch of problems on the back. Actually, all of them in the second half, numbers 15 through, well, I guess it's really closer to 19 through 22. So the last 4 problems there are just like these 2 things. You're trying to figure out which angles are congruent to each other, which means which sides are congruent to each other, or which sides are congruent to each other. So that must mean their base angles are congruent. So you're either trying to pair up the angles or pair up the base and use that information to find a missing variable. The other thing that you might want to add to this, I'm just taking a quick look here, is the idea that the 3 angles add up to 180. That's how it goes in a triangle. So if I have a triangle here and I have these 2 sides are congruent, and I know this angle up here is 40 degrees. I'm just making one up off the top of my head. That means even though I have no information about these other 2 angles here, I can still figure them out. Oops. Because they're opposite. Oops, I don't know why I did that. Oops, what is happening here? The opposite base angles are congruent as well. And look, we could just make our life easy and call it x, but if one of them's x, then the other one's x. So then we have a relationship here. Those 3 angles, x plus 40, have to add up to be 180. So then I can have 2x plus 40 equals 180, subtract 40 from both sides, and divide both sides by 2, and you get x equals 70. So that's the other thing to look out for in combination of how to set up the equation. You might have to use this idea that the 3 angles add up to 180 to set up the equation as well. So I hope that helps you out, and if not, ask about the questions on Monday. I will talk to you later.